everyone, welcome to Maths IAC. Here is another possible proof question that you can get in GCSE Maths. It's a slightly tricky one. I have not seen this question exactly in a GCSE paper before, but this can be definitely done within GCSE knowledge. So it's perfectly possible that they can ask it. So let's learn how to do this. First, I would like you to give it a try. So the question is to show that the curved surface area A of a cone is given by pi RL. Remember the total area, the surface area of a cone is given by pi r squared, which is the area of the circle at the bottom, plus pi RL. So the question is, you know where the pi r squared comes from. The question is, show that the curved surface area can be given by the formula pi RL. It's a really good question. When you're ready for the answer, press play. Imagine this is a real cone that you made using a piece of cardboard. And I'm going to cut this open. Like, let's say I take a pair of scissors and I cut along this edge. Just take a pair of scissors and just cut like that. And I'm going to just open it so I get something like this. The length here, the length along which you cut is here. Can you see? Now this length here is really the radius of this circle. When you lay it flat, this one. Now, the next thing you need to understand is the length. This length here is the same as this length here. Right, so I know what this length is. This is the circumference of a circle of radius, lowercase r. So this must be 2 pi r. Now that is an arc length for this circle, but it's 2 pi r. Now let's take the angle here as theta. Now I'm going to write an expression for the arc length. So the arc length is theta divided by 360 times 2 pi r. Now r is the radius. Now this is the formula. Now do not get confused by this L. This L here is the arc length formula. Now the arc length here is 2 pi r. Okay, so let's write 2 pi r is equal to theta over 360 times 2 pi radius of the circle. Now, I'm referring to this sector. The radius is L. So let's write 2 pi L. Now, let's simplify this further. So I can see 2 and pi cancels out with these 2 and pi. So I can make r over L is theta over 360. So I can't really go further from here. So I'm just going to leave this for now. My intention is to find the area of the curved surface, which is the area here. So I know the area formula. So area is equal to theta over 360 times pi r squared. So let's do this one. For this circle, the radius is L. So I can replace this r by L. So A is equal to theta over 360 times pi L squared. I can replace this theta over 360 by r over L. How? Because I already proved earlier theta over 360 is r over L. So I'm perfectly fine to replace it here. So let's do that. A is equal to r over L multiplied by pi L squared. These two get cancelled out. So I can show the curved surface area A is given by pi r